नमस्कार, आप सभी का स्वागत है। मैं हूं राहुल और आप देख रहे हैं पीएम ई विद्या चैनल्स और एनसीईआरटी का ऑफिशियल यूट्यूब चैनल। दिस इज आवर लाइव इंटरैक्टिव सेशन ऑफ वेबिनार सीरीज लिसनिंग टू लर्न। टुडे वी हैव सेशन नंबर 42 in which we are going to talk about what do our rivers carry। सुने और सीखें जो हमारी श्रृंखला है, आज उसका ये 42वां संस्करण लेकर हम हाजिर हैं अपने पीएम ई विद्या चैनल्स पर, जिसमें आप आज जानेंगे हमारी नदियाँ क्या ले जाती हैं। जब नदियों की बात होती है तो उनसे हमारी सभ्यता का जुड़ाव होता है, उनसे हमारी परंपरा का जुड़ाव होता है, उनसे तमाम ऐसी चीज़ें जुड़ी हुई होती हैं जो हमारे मन मस्तिष्क में बचपन से घर करे हुए होती हैं। परंतु आज इस विषय पर बातचीत करना क्यों आवश्यक है, ये आज आप बेहतर तरीके से हमारे इस सेशन में जान पाएंगे। हमारे साथ दो खास मेहमान हैं स्टूडियो में। आई वुड लाइक टू वेलकम एंड इंट्रोड्यूस यू टू डॉक्टर गगन गुप्ता जी फ्रॉम एनसीईआरटी। सर नमस्कार एंड वेरी
नमस्कार, थैंक यू।
I would request you to please introduce our invited guest, जिनको सुनने के लिए हम सब यहाँ बैठे हैं और जाहिर सी बात है कि बहुत कुछ जानने की जिज्ञासा हमारे स्टूडेंट्स में भी है, and all the stakeholders, those who are watching this session live on NCERT's official YouTube channel and PME Vidya channels।
नमस्कार दोस्तों, आज मेरे साथ हैं प्रोफेसर वी सुब्रमण्यम, जो कि बायो जियो केमिस्ट्री पर काफ़ी प्रख्यात हैं, इस देश में काफ़ी प्रख्यात हैं, इंटरनेशनली वेल रिनाउंड स्पीकर हैं। दोस्तों, इससे पहले कि मैं आपका मुलाकात प्रोफेसर सुब्रमण्यम से कराऊं, जो कि मेरी दाईं तरफ बैठे हैं, और इससे पहले जरा सा समय आपको इस सीरीज़ के बारे में बताना चाहूँगा एक बार पुनः। यह सीरीज़ अगस्त 2021 में शुरू हुई थी और हमने विभिन्न विषयों पर इस सीरीज़ में लेक्चर्स दिए हैं, सेशंस लिए हैं, जो कि डिफेंस से लेकर टनल्स तक लेकर मेडिकल हेल्थ, न्यूट्रिशन, दिल की सैर हमने इसमें की है, और बहुत सारे और प्लेनेटरी सिस्टम मिशंस, इंडिया स्पेस प्रोग्राम, इस तरह के प्रोग्राम्स पर हमने चर्चाएं की हैं। ये सारे सेशंस हमारे यूट्यूब एनसीईआरटी ऑफिशियल चैनल पर हैं और साथ ही साथ हमारी वेबसाइट ncert.nic.in के इवेंट सेक्शन पर सारे सेशंस अपलोडेड हैं। आप इन सबको देख सकते हैं। आज का सेशन हमारे एक पुराना सेशन जो 17 दिसंबर 2021 का हुआ था, जिसमें हमारे साथ लखनऊ से श्री रविंद्र सिंह भदौरिया जी जुड़े थे और उन्होंने वाइल्ड लाइफ कंजर्वेशन पर बात की थी, जिसमें कि उन्होंने चंबल नदी के किनारे घड़ियाल के पुनर्वसन को महत्व दिखाया था। और उसी क्रम में आज हमारे साथ प्रोफेसर वी सुब्रमण्यम हैं, जो कि फॉर्मरली जेएनयू से। मैं उनका तारुफ अब आपसे कराता हूँ, आपकी मुलाकात कराता हूँ। प्रोफेसर वी सुब्रमण्यम, आपका बहुत बहुत स्वागत है हमारे स्टूडियोज़ में, NCERT studios में। Professor V. Subramaniam, who is presently the mentor with the Department of Natural and Applied Sciences, Terry School of Advanced Sciences, New Delhi. He is a renowned scientist and a pioneer in the field of environmental sciences. He is a teacher of teachers' friends. He is very senior teacher, very senior scientist, very respected person among the teachers fraternity across the country. Dr. Subramaniam has been with the School of Environmental Sciences, Jawaharlal Nehru University, New Delhi as a professor and then as UGC Emeritus Professor. Dr. Subramaniam obtained his Masters in Geosciences in 1966 from the Jadavpur University and won the gold medal. I was just 1 year old at that time. A Fulbright scholarship at Yale and at Illinois, Chicago culminated in a PhD degree from Northwestern USA in 1973 to him. An exemplary academic, he has been pioneered the field of environmental sciences in India and seminal research contributions. The significant academic positions held by Dr. Subramaniam include advisor Amity University, coordinator DRS program in biogeochemistry at Jawaharlal Nehru University, professor and dean School of Environmental Sciences JNU, faculty at the McGill University, Canada, guest faculty at the Delhi University and Delhi College of Engineering, which is now known as Delhi Technical University. Dr. Subramaniam is also a visiting faculty at a number of international and national institutions, including the Oxford Brookes University, United Kingdom, University Antwerpen, Belgium, CNRS, France, Hamburg University, Berman University, Germany, University of Delaware, USA, and University of Uppsala, Sweden. Dr. Subramaniam has been a Hansen Fellow at the Institute of Advanced Study Delmenhorst, Germany in 2004, and also a Palme Fellow at the University of Uppsala, Sweden during 2003 to 2006. University of Uppsala, Sweden in fact has also nominated Professor Subramaniam for the Stockholm Water Prize 2003. It's continued there for 5 years. His areas of expertise encompass many areas including the environmental chemistry, river water quality and quantity, environmental quality, environmental impact assessments, water and environment, geochemistry and natural mineral and water resources, pollution, river basins and hydrology. He has supervised over 35 PhDs and 85 MPhils in his last 40 years in water chemistry, geology, environmental sciences and climate sciences. Professor Subramaniam has authored or co-authored more than 175 research publications in peer-reviewed international journals and 13 books besides contributing chapters in several international books. Professor Subramaniam has also been the editor-in-chief and reviewer for many international journals published by Springer, Elsevier, Oxford, etc. Completion of several national and international research projects with focus mostly on water, sediments, sediment cores, chemistries, etc. is also credited to Professor Subramaniam. Professor Subramaniam, एक बार आपका पुनः स्वागत है। और ये जो आज का इशू है, हमारी नदियों में क्या जाता है, हमारी नदियाँ किस तरह से बिहेव करती हैं, किस तरह से मुड़ती हैं, किस तरह से सिविलाइजेशन में इसको सपोर्ट कर रही हैं फ्रॉम एंशिएंट टाइम्स. I am sure this viewers, I am very sure that this session is going to be very entertaining session for all of us, very informative and very knowledgeable session. It's all yours now, Professor Subramaniam. Thank you.
Good morning to all of you, all the stakeholders, particularly the youngsters who are listening, the Listen and Learn and Listen program. The good concept actually for youngsters to interact with people from different walks of specialization and learn about different subjects and probe the mind. Basically, what is science? Science you have to probe, you have to be curious, you must have ability and interest, learn, curious to know, because curiosity is one of the benchmark of any scientific understanding. So I picked up a title which I thought might be appropriate for school children. Since I am a man of rivers, I worked on practically all the rivers in the country, right from Brahmaputra to Indus to Cauvery to the western flowing rivers. All the rivers basically I have touched at one time or the other through my students' help. And so I thought it may be a good idea to share with the youngsters, the coming up generation, what are the simple aspects of river which they can explore later on in a more detail if somebody is interested, pursue one or the other. So I have deliberately prepared my PowerPoints in a generalized way, simplistic way at the school level, because otherwise I will go in a tangentially a hi-fi complicated equations all, that is not the intent of that. So now the first one I have highlighted, let us take some time to understand this, because all other PowerPoints are going to be based on this. I have given you a long list here in this transparency, the slide, the various components of a river system. For example, the very first thing, stream, channel, river, river basin. These are the basic elements of any riverine hydrology. What do you mean by stream? What do you mean by channel? What do you mean by river? Actually, the three terminologies are used interchangeably. In any literature you survey, some people may use simply the word stream, some people may use the word the channel, some people may use the word river for everything under the sun. But there is a operational sort of a understanding. Normally stream, the word stream is used to describe a small water flowing through a very small narrow stretch of land. It may be in the hill, it may be in the plain, doesn't matter. So stream is basically a very small scale order, water carrying capacity. The channel refers to the different channel. Nowadays you are talking about the YouTube channel, but this channel refers to a geomorphological terminology. Channel is basically the road or the right of way through which water is flowing. It may flow from point A to point B. So any such route can be considered as a channel for a stream or a river. Where a river River itself means a slightly bigger object compared to a stream. It may cover a small area or bigger areas. So, that is what is called river. A river may or may not flow all the time by carrying water, etc. Then river basin is a composite terminology. When you say river basin, it may contain many rivers within them. It is a larger area where the water is coming from different parts of the basin. So, that is a sort of a composite terminology, river basin. So, river basin may contain, for example, a very large number of rivers. Take for example the Ganges river. Ganges river basin is very big. It covers several millions of square kilometers of northern India, and it has many major rivers by itself, like a Yamuna is a separate big river. You have a Gangetic, Gomti, Gagra, Kosi, Son. Each one of them are big rivers and themselves having a river basin. So, river basin is an integrated version of many small order river, small order river basin, etc. composite together. Now, next sentence you see the catchment area, tributaries and distributaries. A river gets its water from the catchment area. The very word catchment, that means the entire area from which water is contributed to the river by natural processes. Normally a catchment area will be in a hilly terrain, so that whenever rain falls there or the snow melts, the water will flow from that area and go to some main channel where the river is actually flowing. So, that becomes a catchment area for that river. So, catchment area sometimes could be very small for some of the small rivers, it could be very large for something like Brahmaputra and Ganges, etc. So, scale varies depending on size of the river. For example, you have a very small river in Rajasthan, Gujarat area, Luni river. Luni is a very small river, tiny river, hardly a few hundred kilometers long only, and also carries water, very short duration in a year, maybe a 10 days, 15 days maximum. On the other hand, its catchment area is also very small, it is getting from small lake, overflowing of rainwater from the adjoining hillock, etc. Extremely small area, few hundred square kilometers, that is all the catchment area. On the other hand, look into the Ganges, it is getting water from practically the entire part of North India, right in from the Himalayas, non-Himalayas region. Son, for example, one of the rivers contributing to the Ganges, Son is not draining the northern India, it is draining the central India. So, Ganges getting water from such a wide area, so its catchment area is very large, very diverse in geology, geomorphology, climate, topography, forest cover, etc. Extreme diversity. Now, next I have mentioned in the tributaries. So, water that is coming to a river, it may be due to a number of smaller rivers which are finally merging with a mother river. You call it a mother river and smaller river. Take for example Yamuna and the Ganges, because we are just in Delhi, we can see them very close to each other. Both of them are originating, the catchment is in the upper part of the Himalayas, Yamunotri, Gangotri, and they are not very far from each other. But finally they emerge after maybe more than 1500 kilometers of travel to the respective catchment areas, they merge in Prayagraj. So, there until that point Yamuna can be called a tributary of the Ganges. Similarly, Ganges has many other tributaries like a Gangetic, Gomti, Kosi, etc., etc. So, tributaries are those rivers which bring water to a main river or a mother river. So, you can think of tributaries as a daughter rivers. On the other hand, distributaries is a process by which the mother river at certain point, maybe the end of the river mouth, etc., they break up into small channels and distribute the water over a larger area. What it brought from a single route, it is now distributing at the end of the river process into multiple channel. And there are examples like the Cauvery river, the Ganges river, when the river ends, the river mouth, for both of them large number of distributaries. If one looks into the map of Cauvery Basin, You can see at the end of the river mouth in Trichy, this is actually my hometown. After that it breaks up into more than 20-25 channels. So it becomes a distributaries. But Cauvery don't have too many tributaries. It has very less number of tributaries compared to the Ganges. So tributaries bringing in water, distributaries remove the water to distribute to other parts of the basin. So both are exactly opposite for this house. Then a river has a certain sort of a processes that goes on. One is the catchment area, we mentioned it. Then you have a middle or plain areas. Normally most of the rivers have a middle terrain. Normally it loses its force of flow in the middle part of the river. So it may be sort of a flat or literally flat and water flowing rather slowly. And most of the river basins, the middle part is where the population density is generally high compared to catchment area region. So almost every river has a reasonable number of middle or plain part, but there are certain rivers, the middle part of the river may not be plains. Take the case of Narmada. Narmada is a reasonably good sized river and it is originating in a catchment area from a sort of a small area known as Amarkantak. But then population density in that area is quite good. But once it comes to the middle part of the river basin is sort of a hilly catchment, forested hilly catch areas, and there the population density is also low, highly forested, highly hilly. That is a central or middle part of the river. This is different from many other river basin. On the other hand, Cauvery. Cauvery, you have a density of population quite high in the middle part in Karnataka and very high also in the downstream part in Tamil Nadu. Its catchment area sparsely populated hilly. So river has basically three well defined region: catchment, plain and end of the river. Now end of the river, sometime it does not go directly, it meanders. Meanders means sort of going in a circular fashion, because a river water flows in a direction where it can easily flow. In that process what can happen, that be some obstruction could be there. Obstruction could be some island has come up, some hillock has come up or some forest has come up, then it will try to go around that area. Now sometimes the going around the area could be quite visually appealing. When you look at the map and a satellite based imagery, there are many rivers in the world which meanders, because rivers do not flow in a straight line. It is not like a railway track going in a straight line. No, rivers are the natural. They will meander through those areas where the water can find the easy way to go. So that is what a process known as a meandering. Brahmaputra is well known for a highly meandering component. When you look at it from satellite, the Brahmaputra, a lot of meander channels can be seen. Many rivers at the end of the mouth region, they also establish what is known as a river islands. River islands are basically landmass either created by the river itself due to accumulation of sediments. The sediments accumulate so much, the river decides to go around that. So in this process, over a period of time, an island develops. One of the best known example of this, Brahmaputra, Majoli Islands. The Majoli Islands in Brahmaputra entirely created by the river during flood times when a high amount of sediments are dumped. Over a period of say 30 years, 40 years, 50 years, 100 years, so much sediment has been dumped, it has become an island by itself, and Brahmaputra goes around the river on the left side and right side, etc. And incidentally, the Majoli Island in fact is known globally the largest river island in the world. On the other hand, islands can also come up in a river system because of certain natural obstruction. Natural obstruction could be, for example, a rock. A massive rock is on the way, so the river has to flow around the rock. If it is does not have the capacity to break that rock. Cauvery is an example where you have both rock dominated islands are there right in the middle of the river. Cauvery has three major river islands, one near the catchment area, very hard rock to break, so the river flows around it, creating a rocky central island in the middle of the river in the upstream area. And again in the middle part of the Cauvery river near Mysuru, it has created an island, again due to rock obstruction, that is known as Srirangapatna. Island is created, and that island created is known as a Rangantittu, which is a bird sanctuary actually. But also again a rock. On the other hand, the downstream part of the same Cauvery river near the river mouth, before distributary of the river starts into hundreds of distributaries, you have an island called Srirangam. That island again is a sediment coming from the Cauvery and another small river joining the Cauvery. That sediment has dumped it because the flow velocity is very low, is unable to carry that sediment. So an island has been created by the river itself, similar to Brahmaputra. So there are three major islands in the route of Cauvery. All these are river islands, but they are all small islands compared to the Majoli Islands in Brahmaputra. So river mouth of course is a process where the river no longer can be called a river, because the river ends there and creates what is known as a delta. That means instead of emptying directly into the ocean, the delta is created, which is a zone of interaction between a river and the ocean. So the delta areas could be sometimes very small, sometimes could be very large. For example, in the Sunderban Delta, in the Bengal Ganges system, the Sunderban Delta is created by both the Ganges and Brahmaputra, because they merge in the delta. So it is considered the largest present day freshwater delta in the world. Many rivers flowing out of the land into the ocean Bay of Bengal, they have a delta of varying sizes. Godavari has a delta, Mahanadi has a delta, Krishna has a delta, Cauvery has a delta. On the other hand, west flowing rivers like Narmada, Tapti, and as well as many other west flowing rivers in Kerala like Periyar, Achankoil, etc. All these west flowing rivers which empty into Arabian Sea, they do not have delta. Why? They do not have delta because the routes are generally very short. They hardly a few hundred kilometers long only, most of these rivers. Basically there is no sort of a flat land available, significant amount where delta can develop. So catchment area, middle area and river mouth, all of them are very close to each other. So they do not have the capability to develop delta. So the west flowing rivers, you can forget about any delta formation. East flowing rivers, all of them have small to large delta. One of the reasons delta is important, deltas are very fertile ground, a biologically enriched ground, it is a teeming life. Sunderban Delta of course is well known for Royal Bengal tiger, is endemic to that area. In addition, you have a huge amount of different species of fishes, etc., plant, mangroves, etc. All of the delta in the Bay of Bengal coastal areas, all of them have a fantastic life, living processes, aquatic life, etc. In addition, large amount of sediments are dumped into these delta, and many of the deltas are also energy resources. In fact, the Godavari Krishna delta area, gas and oil are being currently extracted from the delta area, from the Paleo River channel. Similarly, Cauvery delta, gas is being extracted. So deltas are veritable living processes created by the river before they completely empty into the oceanic areas. Now, you wonder how old are our rivers? Did they form in front of us yesterday? They have been there forever, ever since earth came into being? It's a good question to think about, because if you look into the continental map of the world, you look into continents in terms of Lego pieces, and many times in the past many of the continents were in a different location, different combination than what you are seeing it today. So over a long period of time, what is known as plate tectonics, we are today seeing where the continent as they are. But some of the continents also have rivers which almost correspond to the time before they broke up. The oldest river in the world is in Australia, and there the age of the river estimated based on the sediments dating etc. about 400 million years old. This is the oldest river in the world. On the other hand, you have a very young river, Amazon River. You have very young river, Amazon River, that is very young, is only 11-12 million years old. So, you have very old to very young river system, and that is one. Go back to that.
Yes.
Now, let me go point by point. Okay. So, age of the river varies anywhere from say few hundred million years, because of a pink river in Australia, to very young river Amazon, which is about 10 to 11 million years old. On the other hand, our Ganges, Brahmaputra, take the case, how old they could be. If you notice a map of India, map of South Asia, including the Himalayas, you will see the Brahmaputra originates in Tibet, whereas Ganges originate this side of the Himalayas, Brahmaputra the other side of the Himalayas. Because they are on either side of the Himalayas, Brahmaputra is older than the Ganges. It is estimated, scientists have done the dating of the river using certain modern technology. Brahmaputra is something like a 50 plus million years old. The Ganges 40 minus million years old. The oldest among all the Himalayan rivers is the Indus, and Indus is about roughly 60 million years old. So, age of the river, you are not talking in terms of the 1 year, 2 year like that. You are talking in terms of the millions of years, because that is what the time it takes for the river channel to develop. As a result, you also have in the geological history what is known as a Paleo River channel. After all, continents have been there, oceans have been there in the past, the atmosphere has been there. So, rivers were also there in ancient time. Because the rivers are also in ancient time, you also have sort of a Paleo River channel which one can see now through investigation etc. Now, let me show you couple of examples. Is a Ganges river basin, a network of tributary. You can see so many rivers are there in this river tributaries coming from different direction. So, each one has themselves are big, like a Son river, Yamuna river, each one of themselves have their own sub-basin. For example, one of the tributaries of the Yamuna itself, Chambal river. Chambal river is well known before the junction with the Yamuna. It has a gharial sanctuary, it is a habitat for gharial. Like that, each of the riverine system, a tributary of the main river, they are the habitat for various types of aquatic organisms. The Ganges itself, you must have seen through many movies and documents etc. Dolphin is a famous aquatic organism that populates the Ganges in many parts of the Ganges, particularly the middle sector of the Ganges. Now, on the other hand, Cauvery, shown here the example southern river Cauvery, unlike the Ganges here, this Cauvery river, see the end of the river, distributory channel, distributaries are plenty. The river itself is small, narrow until then, but it distributes the water to a wider area. So, there is this example of a distributaries. This is an example of the catchment area. The catchment area, you have the Gangotri Glacier, it originates, and Gangotri Glacier, as you know, is the extreme part of the Uttarakhand, and it is a snowbound most of the time. Is another matter with the climate change scenario, how long the snow will be there, how long the Ganges will get water from the snow. It remains to be seen in the decades to come, how far the climate is changing. This is again the mouth of the river, I told you, the delta, formation of delta. This is the river satellite images of the Gangetic Delta, where you see the water distributes into n number of channels. On the other hand, Narmada, I mentioned an example, it is a middle part of the river in the Narmada, is a reasonably good sized river, is a hilly, forested hilly with low population density. The bulk of the population density in Narmada in the upstream part as well as a low stream part, not in the middle part, quite contrast to many other rivers, in contrary to many other rivers in India. This is again the satellite imagery of the delta. Look in the much higher satellite imagery, you see what is the impact of the river into the ocean. The water goes well beyond the boundaries, geographical, physical boundary of the continent. It is estimated, some of the isotopic data that has been derived from the studies of sediments in the Bay of Bengal, the fresh water of the Ganges Brahmaputra can be located almost 1000 kilometers away from the continental interface. That means there is a power of the river water to push the sediment way deep into the ocean. The Ganges Delta is one of the example of that. On the other hand, another smaller delta, this is a Kaveri Delta. The reason why I am showing you this, because it has a very long historical record. This is a Kaveri Delta, and this is a water has accumulated here due to a barricade, you call it, is called known as anicut, and it is the oldest anicut in India. This was built by one of the early Chola king in the year 100 AD. Imagine, you are talking about anicut built in the year 100 AD. Then British then modified it a little bit in late 19th century, modernized a little bit as per the technology available at that point in time. And again in 1980s, the modern day governments in Tamil Nadu improved it further to a modern looking type. So this is the oldest sort of anicut or dam. Anicut is nothing but an ancient dam in the country, and it is still operational. This was built on the Kaveri Delta to make the water go to many other artificially created and natural channel as well, make the water flow into irrigating area in a larger extent. So many of the delta area, even though the river itself, Cauvery itself is not very big, they do not carry that much of water throughout the year, unlike the Ganges. You see how much water has been blocked, it is being distributed because of the building of that. I mentioned you an example for meandering. This is an example of a meandering of the Godavari River. Godavari River is the biggest of the peninsular rivers, and Godavari River also carries a lot of sediment. You can see the brownish color here. So meandering, it cuts through certain areas where it cannot flow comfortably, goes around it. Whereas you can cut through, it will cut through. If you cannot cut through, move around it, like a diversion in a road, etc. All the rivers in the world, not only India, other parts of the world, rivers are associated with civilization itself. All of us of course know about, because we are in India, we know about Indus Valley civilization, but many other river valleys in the country, in the region, in the continents are associated. For example, we know very well the Middle East civilization, as ancient as Indian one, the Chinese one. Similarly, things like European civilization in Africa, Egypt, Nile civilization, all of them are river based. Modern day, of course, many of the big cities in the world, they are all located on rivers. For example, Paris. Paris, the river itself is a small river, Seine river, but the Seine river itself is small, but ancient time, one of the literally Neolithic population used to live in that area, and they were known as a Parisi in the local language at that time. So the city came to be known as a Paris in the modern day time. Similarly, Mekong River, many cities are located through so many countries in Southeast Asia. Of course, at very close at home, Varanasi and Kolkata, they are located on the Ganges. So many regions in the world, cities have been the center of modernization and civilization as well. Looking to the river map of India, there are rivers, small, big, covering small area, large area, where practically every part of the country is covered with one or the other rivers. That is why India is known as a subcontinent. We have got the rivers of diverse characters. An example of the organisms in the river system, this is the Gangetic dolphin, and Gangetic dolphins are very interesting animal. These are all freshwater dolphin. You also have the saltwater dolphin, you have the Indus dolphin, you also have the Brahmaputra dolphin, and you also have the dolphin in the Irrawaddy River in Myanmar. Now, the difference between the Ganges and the Brahmaputra dolphin, the Brahmaputra dolphin is generally known to be blind, unlike the Ganges dolphin. Actually, the Brahmaputra dolphin is not blind, but it has learned the ability through successive generations of dolphin multiplication how to navigate in an extremely muddy river. So, very muddy river which Brahmaputra is, the dolphins are able to navigate by themselves without actually looking in which direction they are going. So, they are popularly known as a blind dolphin. In reality, they are not blind. Whereas a Ganges dolphin, they are quite normal dolphin, they can see, they navigate after looking, etc. Dolphin is an important species in a riverine system because they are the big guys, you can see the size of that, and they also help in controlling the population of many other aquatic organisms. When you talk about rivers, you also have to talk about processes plus and minus points of river system. Because of the misuse of the rivers by human being, floods have become a very common phenomena. River-borne floods have become very common phenomena. This is an illustration that just happened 2 months ago in Himachal, in Kangra area of Himachal, Chakki river, a small river, but because it is a hilly terrain, high altitude hilly terrain, it was carrying huge amount of boulders, etc. So, flooding has happened in the neighborhood area of that river. But occasionally the flooding is not something you see only in Himachal or states along the Himalayas. You see it everywhere. This is the floodplains of various river systems in India, and the floodplains are the product of floods, provided you allow the flood water to stay instead of misusing the river bank for construction, etc. When you start obstructing the river bank, that is the sides of the river, due to human requirement, either settlement or agriculture, etc., you are actually interfering in the flow pattern of the river. So, instead of forming floodplain which are highly nutritious, rich nutrients are stored in that very fertile area where the water is stored temporarily by the river itself to accommodate high flow, you are interfering with the floodplain area by construction, etc., that leads to flooding. So, we call it a urban flooding, that because it is a man's creation due to misuse of the river. This is an example of the urban flooding in Kerala just 2 years ago, and look, here is a satellite imagery. Kerala is a densely populated state and it has many smaller rivers, not very large rivers in the other like other parts of India, but because of extreme pressure on the land, urbanization and real estate exploitation of whatever available land, the urban flooding happened in Kerala in 2018. But we have frequent urban flooding in Bangalore. Just earlier this monsoon period in the month of August 2022, there was a heavy flooding, you would have seen TV images, etc. Even the IT city in Bangalore, people have to use boat to communicate. These urban floodings are because of misuse of natural water bodies including rivers by encroaching on the floodplains, and floodplains are actually the essential component of natural river system that should not be meddled with. I mentioned about the Paleo Rivers earlier. Many ancient rivers have left behind ancient river channel, we call it a Paleo channel. Now, is an example here for the Ganges, just near in the Prayagraj district, a old Paleo channel that linked actually Yamuna and the Ganges have been discovered now by scientists. It is now under investigation how old this Paleo channel, Paleo river, small river linking the two rivers before the junction in Sangam. So, small channel has been discovered now. Now, Government of India, similar to an example set by New Zealand, has given a human rights to the river Ganges and Yamuna. They say Ganges and Yamuna should be treated as a living being. So, they must as much human rights as you and I have. This is a new thinking to manage the river systems in the world. I mentioned about the erosion because most of the river system in the world, after all, river deals with water. Water has got energy. Because of the energy, sometimes very high during a high rainfall area, sometimes very low during low rainfall time. This energy is utilized by water to erode. Erosion is a natural process, and erosion happens primarily due to water. It can also happen due to wind. So, Brahmaputra is a river which undergoes erosion tremendously, and there is an example of a erosion that has happened in Brahmaputra in some of the harder rock areas of the Brahmaputra, and the erosion rates are very high. So, the erosion also is accompanied by what is known as a deposition. It is an example of the Indo-Gangetic alluvial deposition that covers several thousand square kilometers. That is the alluvial deposit between the Indus River and the Ganges River. Though the whole area is known as the Indo-Gangetic alluvium. That is a deposition of eroded sediments over a period of time, and it has happened, and that is the most fertile part of the subcontinent. So, erosion and deposition are natural riverine processes. It is a continuous process. It has happened in the past, it will continue to happen in the future as well. One of the sort of pressing questions in front of present population in India, as well as youngsters like you have to handle it in the days to come, is the pollution of the river, because rivers carry lot of pollutants, man-made chemicals, man-made objects, etc. This government has come up with an elaborate scheme to monitor the quality of many rivers in the country. This is an example for the river Ganga. The Central Pollution Control Board has a network of monitoring locations, where many locations either they continuously monitor, or local agents, sub-agencies of the same CPCB monitors it in a seasonality, etc. So, monitoring a river quality is an essential component of preserving the nature of the river. Is an example, what are the parameters which CPCB have been monitoring, which are observed to be abnormal, subnormal, or not desirable. This is a simple illustration, may not be possible to read each one of the graph in detail, but it suffices to know here that monitoring the river water quality for a various types of pollutants like a biological oxygen demand, etc., is a very key element of preserving a riverine system. This is a continuous process. Not only CPCB does, many state government agencies also do, not only for the Ganges, for all rivers in the country as well. I mentioned about the ancient rivers to modern rivers. You can see the very ancient rivers, more than 300 million years old, whereas the most recent rivers, the Amazon is very recent, hardly 11 million years old only. Our Nile and Indus, they are not that ancient. They are ancient, of course, in relation to the Amazon, but then some of the rivers could happen to be as old as the dinosaur age. For example, some rivers in India are much older. Southern rivers are much older because they are in the hard rock area. Originally India was only the southern part of India when it was a part of Gondwana land, and then they started drifting due to plate tectonics and formation of the Himalayas. Then only the rivers in the Himalayan system started coming up. So, southern rivers are much older than the northern rivers, and some of the younger or older rivers could be as old as the dinosaur in the Jurassic Park age. I mentioned about the west flowing rivers not having delta, east flowing rivers are having a lot of delta. Now, there are many other rivers also having a very great depth, amount of freshwater carried is very large, like one of the rivers in Central Asia, which finally ends up in the Pacific Ocean, Yenisei River, one of the longest rivers in the world. It has a lake Baikal, a freshwater lake, huge lake. Is about 1600 meters deep, almost like an ocean actually, right in the middle of the Siberian subcontinent. So, we have many other rivers also which are very deep, and some of them are very old. For example, you have the Congo River. Congo is the deepest river. Congo River is located in Africa, is a hard rock area, but it is as deep as more than 200 meters. So, none of the Indian rivers qualify because most of our rivers are shallow, hardly 10 to 20 meter thick maximum. I mentioned about the Majoli Islands and Brahmaputra. There is the largest freshwater island in the world. Because of the sediment that Brahmaputra carries, periodically it dumps the sediment because it is unable to carry that much of heavy load of sediments, velocity has come down. So, accumulation of such sediments over a period of time in the course of the river has given rise to the Majoli Island. Majoli Island now in fact is a separate ecosystem because it is cut off from the main Brahmaputra river now. So, it has developed its own ecosystem now. I mentioned about the islands, river island, Majoli was one of them. This is similarly a Srirangam island, satellite imagery, aerial satellite imagery of a Srirangam island, which is formed by the river sediment, unusual formed by the river sediment of the Cauvery River. The color of the rivers are very interesting because the color is what you first observe when you look at the river. This is an extreme example how contrasting colors could be. This is from Amazon in Brazil. The black color you see is known as a Rio Negro and the brown color is a Rio Amazon. The black color is not due to pollution. Rio Negro is flowing from a tropical rainforest catchment. It has a lot of organic matter, hence it is black. On the other hand, Rio Amazon is flowing from the Andes mountain, glacier mountain. So, it is carrying only the silt, no pollutant, so it is a brownish color like the Ganges. So, this color combination in the Amazon being the largest river in the world, this goes for more than 1000 kilometers, finally the colors merge. On the other hand, we have a river, Damodar river in India, which is also black, but that is not black due to any tropical rainforest, it is simply pollutant contributed by the industries in the nearby areas. So, one of the things we have to take a note of, pollution of a river, how bad it is, quality of a river, what does it carry? In addition to pollutant, a natural sediment, and sediments are basically the nutrient that supports the agriculture, that supports the aquatic organism. So, if you play with the sediment, you are using the river sand for construction industry, you are actually taking out the nutrient part of the river and making it basically a dead system, which is not good. So, sediment, the chemical part, the root of a river that takes obstructing the root for extracting water or extracting energy. So, many interferences, there are many human interferences in the riverine processes, and because of these interferences what you see rivers today is not what they are supposed to be. So, human beings have put a very strong signature on the riverine processes, both the hydrological process involving the water, geological process involving the river flow direction etc., and quality processes in terms of playing with the quality of a river water itself. So, it requires a collective combination effort and multi-discipline task, because a riverine, a natural system, multi-stalked natural system, a river can do many things at a time. I mentioned here is a multi-stalked system without human intervention, without technological intervention, it does so many things: historical support, flooding, natural flooding, agriculture, fisheries, aquatic life, civilizations and spirituality. After all, everybody dies and eventually river is a player where the body ends up. So, river has a multi-task accomplishment naturally without technology intervention. Let us make an effort to keep it that way, so that it is a sustainable future for next generations as well. I would welcome any questions anybody can have. Please free to ask me questions.
Thank you very much, sir. Yes, today we have witnessed Professor Subramaniam, गुरुओं के गुरु. सर, आप वाकई में आज we have learnt a lot, and your flow of speaking, your flow of presentation was really amazing. We all enjoyed. Now we will take up some questions one by one.
Please.
We'll like to have some water in place, sir.
Actually, thanks for watching this session. We have so many viewers. I request you all, if you have any more questions, please send us through our NCERT's official YouTube channel, as this program is live streaming there. One of our viewer, Misho Singh, sent a message, quite an informative session, lecture this is. And Aarti Sharma sent a question that in case of rivers, we also use a word riverbed. How is it different from catchment area?
River?
bed.
River bed.
River bed, as the very name implies, is a bed of the river. River has a vertical proven, it has a depth. So the bottom of the river, sediments carried by the river accumulates over a period of time. So that is known as a river bed. Whereas river is a water carrying part of the river. So river bed is the bottom of the river. When you go put a stick, for example, in the middle of the river, it will touch a bottom, stable bottom. What is that bottom? It is a sediment accumulated from the river. That is known as a river bed.
Sir, Professor Subramaniam, the question seems to be a little in perspective, as we say in Delhi, for example.
Yeah.
We say that often, I mean, there are many buildings which have come up in the Yamuna river bed. For example, the whole of the Millennium Park is considered to be on the river bed. Do you mean to say that at some point of time the Yamuna was so wide that the Yamuna was flowing through those areas?
Well, historically, if you know the recent last 300-400 years history, Yamuna was flowing where the old fort is now. And
Yes.
those were built originally because river was flowing there at that point. Now encroachment has gone all the way now. So the river, what was once such a wide river, has become very narrow because land use pattern has changed, either for agriculture or for building, construction, etc. It has changed, and that is coming in the way of water flowing freely. So you get urban flooding. Periodically you get during monsoon period, the people are evacuated because they are occupied an area they are not supposed to be there.
Yes. So I mean, this has a link to a situation when we see the rivers are narrow at some region, rivers are very wide at some region. So does it have something related with the river beds, that the channels which are formed underneath the river beds take us the water from the river to the catchment areas, and where the river becomes narrow, then they bring water from the excess water from the ground to the rivers. For example, if I see the Yamuna, for example, the Yamuna, the width of Yamuna is shallow in Delhi, but it becomes very wide when it meets around Allahabad to the Gangas.
You see, from here to Allahabad is a long way, is more than 1000 kilometers. Between these two locations, Yamuna has a large number of tributaries, Kain, Betwa, Chambal. These tributaries themselves also bring water. They also create a river channel. So the combination of what you see, all of them put together in Allahabad, Prayagraj area, the river area becomes larger. So sediments carried by the Kain, Betwa, Chambal and the Yamuna channel themselves, they are all cumulatively dumped together in Sangam area. So the channel becomes wider.
Okay.
So that is not a river bed, that is a river channel is widened.
Okay.
River bed refers to the depth,
Okay.
channel refers to the width.
Okay.
Yes, and so what I can understand with this, that probably the groundwater accumulation has not much to do with the width of the water.
Groundwater is always there below the ground, but normally what happens below the river bed means it is depending on how much sediments have accumulated. Sometimes the river bed very shallow, you dig it, water can come from below.
Yes.
Because that is the subsurface water preserved between the sediment which have been deposited. That is what is coming out. In fact, for many of the peninsular rivers in India, very little flow that happens during summer months, like the non-monsoon time, they are nothing but groundwater.
Yes.
Take the case of Narmada.
Yes.
Narmada originates in Amarkantak. Amarkantak is a small tank, from there the water comes, and that water is the groundwater during the low season. Similarly, Godavari, you go to Nasik, there is a tank, it is a very holy place, there is
Yes.
a tank, and again water comes during the low peak season, little bit trickling, that is nothing but groundwater. So in summer, many of the southern rivers, the water coming from the groundwater only.
Yes.
Because there is no precipitation.
no
no summer.
precipitation, yes.
So that is coming from below the river
Below the
bed.
river bed.
Below the river bed.
And this is how it becomes so important not to touch the river
No,
bed.
it should not.
It should not. So because sir, you talked about a lot about tributaries very comprehensively. Can I consider the Srirangam
Yeah.
as a result of when it starts enters into the Srirangapatnam area, then it distributes, and then again after this
Merges.
and then so it again distributes.
The Srirangapatnam is formed by Srirangapatnam, no, Srirangam. Srirangapatnam is different.
Yes,
That's different.
I'm sorry that
Srirangam is an island created by the Kaveri River sediment themselves.
Yes.
Because at that point, before the Srirangam island starts, there is another distributary of Cauvery known as a Kolladam.
Oh,
It
so that's
comes there. So these two rivers separate, then join together. So when they join together, the island is over.
Island is over.
So this island was created by the combination of sediment by the Cauvery, all the way coming from upstream of Karnataka. Kolladam, very small river, local origin.
Oh, I see.
And that again joins with the Cauvery almost towards the end of the island. So the island is actually splitting, joining. The whole island is a sediment of the Cauvery Kolladam system.
So the very, I mean, when a student is asking about this particular question, you are saying that the river islands are made of sediments. Many of the islands, for example, the whole Nile Island in the sea, they are supposed to be grown through coral reefs.
Yeah.
So do we have some similar examples in the case of rivers?
Coral reef is not an island. Coral reef
Reef is
basically flow along the coastal part of the ocean, land-ocean interface. That's known as a continental slope. That area where most of the coral are located. And sometimes the coral isle, they get detached from the land, so that becomes a coral island.
Okay. So the similar kind of, I mean, probably the question is like this, that do we have some island in anywhere in the rivers, which are created or developed by living organisms?
There are many instances. In fact, that is how the Charles Darwin evolved his theory of space, origin of life, etc.
Okay.
Because he observed there are some islands created entirely by organisms, not by any water process. Because there are many islands in the Pacific Ocean also, which are all created by the droppings of birds, and they are the very rich phosphate deposit. The whole island created by the bird dropping.
Okay.
But that takes a long period of time.
Very long, million of years.
It's not like one generation, two generations, hundreds of generations of the organism, they build up the island.
One similar question, sir, you mentioned about that the southern rivers do not have a delta and large catchment areas, and the age appears to be the southern rivers in the southern part. It is being considered that the whole part, a larger part, has migrated from the Madagascar and the southern Antarctica.
No, Madagascar was part of Western Ghats.
Yes.
Madagascar was part of Western Ghats. And if you today take out the Madagascar island, which is off the coast of Africa now, it will fit actually between Gujarat and Kerala. That is area. Because it broke away.
They broke away and shifted the whole mass.
This is a process known as a plate tectonics. Without going into
that.
So
what does that mean? So the mean is that the rivers were already flowing in that region?
Yes, it was flowing because that's why the rivers in southern India are much older. Because that is the original part of India. It was in southern India. Because India as a continent did not exist earlier. It is chopped out of the Gondwana land. It broke away from Gondwana land, and that mass of southern India moved north.
Moved towards north to the Erosion.
As they were moving, the sea that existed, Tethys Sea known as, that sediments were bent together, folded, formed the Himalayas. So the river that is flowing out of the Himalayas much later compared to the southern rivers.
That's understandable. That's understandable. Quite understandable.
These ancient guys and modern guys, you can think of it.
Thank you very much, sir. I have larger number of questions with me, but now I cannot take up the time. We are already running short of time, sir.
We've already exceeded the time.
No problem, Rahul, sir, please.
Okay, so we would like to thank you, sir, for your gracious presence, Professor V. Subramaniam, sir. As you rightly described, one of the wonderful session, I must say, we have received so many appreciation messages for you as well. Thank you very much for your time, sir. And Dr. Gagan, sir.
Thank you very much, friends, viewers. You might recall that this whole series, which the 42nd session was today, started in collaboration with the CSIR, Council of Scientific and Industrial Research, and as a matter of collaborating Indian diaspora with their motherland, has now seen 42 sessions. Please do send your suggestions on the kind of topics and we will try to include those kind of topics. Your आपके जो बहुत सारे suggestions हमें मिलते हैं वो हमें बहुत मदद करते हैं और हम उसी topics पर next sessions plan करते हैं. और अभी अब next session हमारा 43rd session friends 28th of October Friday 10 to 11 AM when we will be having Dr. Devapam Das. Dr. Devapam Das, who is working from at the Department of Aerospace Engineering and Sustainable Energy at the Indian Institute of Technology, Kanpur. He will be here in the studios, NCERT studios with us. Thank you very much. Please keep on sending your suggestions. Thank you very much. नमस्कार.
Yes, बहुत बहुत धन्यवाद आप सभी का. हमारा ये सेशन हम यही समाप्त करते हैं. हमारी तमाम प्रेजेंटेशंस के लिए जुड़े रहिए PM ई विद्या चैनल्स और NCERT के ऑफिशियल यूट्यूब चैनल के साथ. नमस्कार.